So in this video, we're going to talk about some applications of the normal distribution. So the area under the curve, basically the area under the curve tells you the probability of something happening. So if you take a set of data and the mean value and the standard deviations, you can basically be able to figure out what's the probability that a certain data entry value or value that you're given falls under that curve. So for instance, maybe you want to know how many people have an IQ of under 85 given the the mean is 100 and the standard deviation is 15. You can do that using the normal curve. And so if we had a z-score table, we would give the probability from the lowest possible z-score values up until the z-score value we are looking at. So it goes from left to right, as you see in this picture here. So notice the green is shaded on the far left, and it goes up until z equal to 1.27. And so if we were asked for a probability that z is less than 1.27, you would go and look for the z-score on the table for 1.27 and the value you needed, and get the values you needed since it includes all the values less than. It basically counts all the area up until 1.27. Okay. So some definitions, we've got standard normal distribution. Random variable x is normally distributed with mean mu and standard deviation 1. And then a standard normal random variable z, when you convert a variable to the standard normal scale. So what you'll see here is, for instance, IQ scores can be modeled from mu equals 100 and sigma equals 15, which is the standard deviation. Clearly, those are not between 0 and 1, as we saw right here on the last slide, right? Because this is the standard normal is when mu is 0 and the standard deviation is 1. So if you have these mu and sigma that are not in that range, what you can do is use this formula down here at the bottom. Oh, skipped it. This formula down here at the bottom, and the formula will allow you to convert it to a z-score, and you can use that z-score to fit, and it will fit in that scale hopefully. And if it doesn't, then you might be looking at a probability of 0 or 1, the whole entire thing, 100%. So next, we have an example. So a pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with mean 38.72 inches and a standard deviation of 3.17 inches. Use the normal model to determine the proportion of 3-year-old females that have a height less than 35 inches. So we'll draw the normal curve, convert the scores on a z-scale, and look on the table for a solution. We're going to do that on the next slide rather than actually work it out. So if we drew the curve, we'd have this drawing up here. Notice that 3.172 or 38.72 is in the middle. That's the mean. You go one standard deviation, 35.5. That's right here. And then 35 itself obviously falls to the left of that. And so there's an area associated with that. Since 35 and 38 do not fall on the z-score table because it only ranges from negative 3.4 up until probably positive 3.4. We can see that we can convert this by using that formula to negative 1.17, and that tells us that this z value, if we were to scale it, would be negative 1.17. So if we use the actual table, you go to negative 1.1, you go to 0.07, and you can see that it is 0.1210. And so what that means is there is a 12% chance that those heights are below 35 inches, given any birth. So we can get the solution using a calculator. You'd push second, you'd put vars, go to normal CDF. We're going to have to explain upper and lower limits, and I will do that on the next video.